Good afternoon, everybody. Hope everything's going pretty good at the summit today. Before I get started, I do have a couple questions for you. So if you can raise your hands or whatever, help me know how to adjust the time on everything. So how many of you have actually used Yarn before at any point in time? Okay, a couple. How many of you are familiar with Yarn, its architecture a little bit? Okay, even more. Good, all right. I'll get started then. So I'm going to talk, this is our experience using Yarn at scale at Yahoo. I guess I'm talking a little loud. So the agenda is who we are. I'm going to go over a bit of who we are, what we do with Yarn, some background on Yarn and Yarn at Yahoo specifically. Go over some of the things that we've run into that were not so great about Yarn, some of the problems that we've had to fix, some of the stuff that still is existing inside it that is yet to be fixed, but then talk kind of a bit about what was good, what we actually benefited from going with Yarn. So first off, who am I? I'm Robert Evans, Bobby. I'm a technical lead at Yahoo on the Apache Hadoop team. I'm a committer, PMC member for Core Hadoop. In the past, I've done all kinds of different things. Linux kernel development for cell phones, some machine learning on top of Hadoop. Right now, I get to play around with all kinds of fun things. I get to play around with Tez, Spark, Storm, more or less whatever I really find interesting, whatever I have time to do. But I'm not here talking just about me. I'm talking about everybody at Yahoo. So the complete Yahoo team that supports Hadoop, not just the developers, but the people who support the stack, the SE team that deploys all the nodes, and also all of our users at Yahoo. I can't necessarily represent them perfectly, but I've talked to several of them and I'm trying to express some of the sentiment they've given me. So, background on Yarn. Hadoop is kind of complicated, especially the release cycle. It started out fairly simple, and this is even a more simplified version. If you go down to that little short URL, it has a much more complete representation of some of the insanity that has happened with the numbering system on Yarn, well, on Hadoop in general. Well, Yahoo's kind of taken an interesting path through all this. We started off going through fairly regularly with the normal, excuse me, the normal releases all the way up to 0.20x. And at that point, there was kind of a fork that happened in the community. Yahoo wanted to add in security. The rest of the community kind of decided to go on without us. So as the community went on with the 0.21 and 0.22 releases, Yahoo forked it and added in security, and that eventually got into the wonderfully named 0.20.2 something. Really intuitive. The community got together, decided that's a really horrible naming convention. We got to fix that. We voted and decided to pull in the append branch also that was allowed HBase, and now you have the 1.x branch, which is the stable branch that exists today out in Hadoop. That's what Cloudera and Hortonworks and most distributions are kind of based off of. Well, at about the same time, we decided we needed Yarn. We needed to abstract away the resources so it wasn't tied completely to MapReduce. And they created the 23 line. Well, 23 being better than 1.0 or more advanced than 1.0 really doesn't make sense. So there was a vote, they pulled in HDFS HA and decided to release the 2.x line. Yahoo, we weren't really sure about the stability of HDFS HA, so we decided to continue on with 23 and keep 23 alive. So what I'm going to be talking about specifically is our experience with 23. The only real big difference between what we're talking about and what is going to be released by Hortonworks and Cloudera is HDFS HA, and from what I understand is pretty well rock solid. We're in the process right now of trying to move to 2.x. So hopefully this year, maybe early next year, all of our jobs will be over onto 2.x. So also, what do we do with Hadoop at Yahoo? We're a little bit different than most of you. And these numbers are actually a little bit off. These numbers are when I submitted the slides. So we have about 40,000 nodes. It's not really 40,000 right now. We've decommissioned some of them. We're closer to 30,000 at this point. We're in the process of tech refresh constantly, so newer nodes, beefier nodes, replacing some of the older hardware. Right now, we do about 500,000 Hadoop jobs every day, 500,000 MapReduce jobs every day. And of those, we consume in excess of 230 compute years. So that's, every single day we do 230 more compute years on top of all these nodes. So right now, actually I checked the numbers earlier, it's no longer 20,000 years of compute that we have on top of Yarn, it's more like 36,000 years. So we have beaten on this quite a bit to really try and stabilize it. So some background for you about the Yarn architecture and how Yarn works. MapReduce originally was the single application on top of Hadoop, that you had a centralized job tracker that kept track of all the jobs and all the tasks that were running. And when a task finished, it would go back and communicate with a job tracker. That job tracker would then decide, okay, I'm ready to launch new tasks. And we really were hitting scalability limits with how much that could handle. And we also had all kinds of people hacking wonderful new ideas on top of MapReduce that didn't make sense for MapReduce. So MPI or giraffe or graph processing, we really needed to pull the MapReduce out and make it more of an application level. And that's what Yarn does. So there's a centralized resource manager. The resource manager is there solely for handing out resources. It's a scheduler. If I want to launch a new application, in this case a MapReduce job, the client will talk to the resource manager and say, launch this application. The resource manager will then go and talk to one of the node managers and inform it and ask it to launch an application master on my behalf. That application master holds all of the MapReduce logic that is specific to how the jobs are going to be scheduled. You know, which ones are going to be map tasks, which ones are going to be reduced tasks, all of that information. And so it will then come up and start asking for more resources from the resource manager to get the tasks it needs to run. And that is kind of how the division came about. So you have a new piece of software that didn't exist before, which is the application master, asking for resources, and so that's how the job tracker kind of got divided up. So, going on with this, what was not so good about this architecture? What were the things that we ran into? Well, first of all, that application master, which is new, it now runs on unreliable hardware. Before, if a node went down, I lost a couple tasks, it's not the end of the world. I'd rerun the tasks, everything would be fine. Now, if the wrong node goes down, I didn't just lose some tasks, I lost all of the history about that app that was running, that complete job. We've fixed that in MapReduce, but it essentially has a log that is writing to the log, a history log as it goes along, to be able to let you know how much, let the next app master know how far it got, so that it can then intelligently relaunch tasks that need to be relaunched and pick up where it left off. Because it is failure code, it only gets exercised in failures, so we did have to do quite a bit of work to make sure that that worked well. But one of the really scary pieces that we ran into is if there's a network cut. Because now we're operating in a truly distributed environment, and there's a single point of state, which is that app master. If the network gets cut, to the resources, the perspective of the resource manager is that that app master no longer exists. And so it's going to try and relaunch a new app master on your behalf. Well, now I have two app masters up and running, and it's a split brain problem. Which one is the correct one? Which one is supposed to actually commit data to HDFS? Otherwise, who knows what could happen? You could get data. You could get all kinds of data problems where you either lose data or your data gets corrupted, and that's really kind of a scary issue. We did solve this also for MapReduce. So right now, each of the app masters, when they come up, they're going to talk to the resource manager in their heartbeats. And if the resource, and there's a timeout on them. So if a new app master comes up, it knows that after a certain amount of time, if the old app master hasn't been able to talk to the resource manager, it'll commit suicide. It'll just kill itself off. So after that certain timeout, it knows for sure that it is the only app master that is up and running. That's how we solved it with MapReduce. But anybody out here who wants to write their own app master, this is not solved generically for Yarn, so you have to be kind of careful with this. Along with this, because it runs on unreliable hardware, debugging has been quite a bit of a pain. That if it crashes, you only get printf debugging, similar to how most of you know about Hadoop, that you're printing stuff out to logs and you have to go through the logs and figure out what happened. Well, it's even more so difficult on the app master because it's just as difficult, but you have multiple jobs and it's much more complex than a typical MapReduce job is. And then the other issue is that a MapReduce, an AM, again, an AM can run on a slow node. You don't have just complete failures of nodes. And so if an AM is running on a slow node, it can get bogged down with all the events that are coming in from the various tasks. It's very difficult to solve this generically. For MapReduce itself, we solve this for tasks by having speculative execution. If I see one task that kind of appears to be slower than everybody else, I'll launch a copy of it. The first one done wins. I can't really speculatively launch a new app master. It doesn't really make a lot of sense as to what's going on there. So this is one that we still haven't solved yet. If you have some bright ideas, we'd love to hear about them. But for the most part, it is something that we still have to deal with. The other issue, too, is sizing the app master. Previously, because the job tracker was a single point, and so I could throw lots of memory at it. And on average, I'd have a couple big jobs, lots of small jobs, and for the most part, the big jobs would be fine. Well, now with a split-apart app master, if I only give it a gig of memory, there's a very limited number of tasks or task attempts that can run within that space of memory. And so we've done a number of things to really optimize this. And the default heap that we run with is 1 gigabyte. We've optimized it so that you can fit about 100,000 task attempts inside that 1 gig heap. But worst case, that means, because if tasks fail, they're going to be relaunched, that's about 25,000 tasks that can run absolute worst case within the heap. It's not an insurmountable problem. In fact, 25,000 tasks is a lot for the vast majority of people. We have a few jobs that are quite a bit bigger than that. So it shouldn't really be that big of a deal, but it is something to be aware of, that if you do run a very large job on MRV2, there is the possibility that you'll get out-of-memory errors, and they can seem kind of misleading as to what's going on. The other issue, a little hard to read, it looks like my filters are not working as well, but so essentially there's lack of flow control inside the app master. And also inside the resource manager. So what that means, so the new architecture for the app master and the resource manager is an event-based system. So when a task heartbeats in, that gets translated into an event that will get processed in a state machine somewhere. Well, there's no flow control inside this. And so there were times when we had lots of tasks running and the resource manager would get bogged down and would start to fill up with lots and lots and lots of events. And there was one point in time where we were literally 2 hours behind, that we had several gigabytes of stuff in a queue waiting to be processed, and the app master, the resource manager just couldn't keep up with all the events that were coming in. We've solved some of this. We have put in a number of things to be able to kind of flow control on the periphery of the resource manager. So as events come in, if the resource manager isn't really quite ready to handle all of that, then there's a bit of a pushback. It's not all the way in place yet. It's still in the process of being put in. But for the most part, if you're running on fairly decent hardware and your cluster isn't 2,000 nodes like a lot of ours are, you're not really going to see too many of these issues. But the biggest issue that we ran into is actually the load that was placed on the name node. So Yarn launches tasks a whole lot faster than the job tracker MRV1 used to. And what's more, remember what I was talking about with the recovery for the app master is keeping that log of everything that happened inside HDFS. And it's syncing that log quite regularly on boundaries of very important events. Just to be sure that when it crashes, those events have been put onto a platter somewhere and can be brought back up. But the biggest thing by far is log aggregation. We have lots and lots of jobs. These jobs are very big. They tend to get spread out across the cluster. And so one of the features that Yarn provides is the ability, when your job is done, to take all of the logs associated with that job and place them in HDFS. And that's great for debuggability, but we have so many jobs running, those 500,000 jobs a day, that it can really fill up HDFS. So right now, when we first started doing this, 7 days of logs were taking up 30% of the total namespace. So 30% of all files on HDFS that we had were aggregated logs. That's a lot, especially for us. We have lots and lots and lots of files. What's more, we saw the write load on HDFS itself for the same jobs was 50% higher. 160% more rename operations were happening. 60% more creates and add blocks and fsync operations were happening. So just the actual operations that the name node had to handle were quite a bit higher. And for us, we're pushing the name node as far as we possibly can to be able to have as much on our clusters as possible. And so this has become kind of a bottleneck for us. We have optimized the name node and the Yarn code to reduce some of that load, but there still is quite a bit of load on it. We're currently in the process of trying to see if there are good ways to either turn off log aggregation or so it falls back to the MRV1 ways, where the logs are still kept on the nodes, but they aren't stored in HDFS, or if there's some other way that we can do something cleaner to be able to reduce that number of logs. Another issue that we have run into is kind of more of a usability issue. It's with the web UI. And it's not that the web UI is bad in any means, it's just that it's different. And because it follows the Yarn conventions, where now there are applications, there aren't really jobs. And when you look at the application, you click on the link to get to the app master, and then you can finally see the jobs that are there. And this works fine, but it takes a bit of a learning curve for all the people who are used to the previous way of doing things, where I'd go to the app master, and I'd go to the job tracker, and there was the list of all my jobs, and I could just click right in through the tasks. It's also kind of browser and JavaScript heavy. So if I go to the resource managers page, it's going to download information about every single job, not just the ones that are running, but the ones that it knows about through JavaScript. That's great, because once it's downloaded, I can now slice and dice it with JavaScript, sort it, and everything comes up really, really fast. But it also is quite a bit more load. And we actually hide a lot of our stuff through a proxy. We set up IP tables and things so that we can't get directly to the production servers. We have to go through a proxy first, and that proxy was rate limiting some of these things. So for us to be able to handle the 40,000 jobs or whatever that it was storing and then download them to us in a meaningful time, we had to play around with compression and a few other things to get that. And that's part of the problem too, is that Yarn itself only remembers a certain number of jobs. So if I go to the resource manager web page, it's only going to remember the last, I think it's 10,000 jobs. For most people, that may not matter that much. For us, on some of our big clusters, that's half an hour. That's something that we've had to play around with and work around to be able to help make it so that there is enough usability that when someone has run a job, something happened, they can go to the UI and actually find their job again and not have too many issues there. Another thing that we ran into is binary incompatibility. So MRV2 still follows the same conventions as MRV1. It still has the same APIs. Your jobs should still run just fine on them, but you may have to recompile your job. Now, for the most part, it is binary compatible. The vast majority of your jobs, and our jobs too, ran without needing to be recompiled, no changes whatsoever. But there were a few specific APIs, especially in the MapReduce API, how there's the MapRed package and the MapReduce package and all of that. Well, there were a few APIs in the MapReduce package that require a recompilation. that really wasn't that much of a problem, but it was something that we had to work through, especially with all of our customers, where they had to be aware of this. A few of them didn't even pay attention, and they started running it, and now, okay, why is my job failing? What's this weird error about binary incompatibility? It's just something that you have to be aware that it exists. And for the most part, it should be binary compatible with your 1.0 applications. So that's enough about the bad. Most of those things on there we fixed, but there is still a whole lot of good that we got out of moving to Yarn. So the operability, and Rajiv's here. It's not an exact quote, so forgive me, Rajiv, if I got it wrong. But most of the issues that we ran into were not with compatibility or incompatibilities with 1.0 or problems with actually running the upgrade scripts or whatever. It's just the fact that we have so many grids with so many applications running on top of them, so many users communicating with them and getting approval from all of them that, okay, yes, you're ready to go, we can upgrade this cluster. But part of this too is because HDFS itself is not compatible. And so it doesn't have a wire compatibility with there's been some work to put into HDFS protocol buffers so that in the future, going forward in the future, hopefully we'll be able to maintain wire compatibility, and newer versions of HDFS will be able to talk to older versions of HDFS without any problems. But with this, when we upgraded one cluster, there were some people in the same colo who were reaching over into another cluster to pull data off directly with HDFS. And because we upgraded one cluster and not the other, there was now this incompatibility, and they had to switch over to HFTP to be able to pull the data down. It wasn't a big deal, but it was something that the customers had to be aware of, and they had to go through, and they had to sign off on. And so it did become a headache just with the vast number of customers that we have. Another thing that we saw was the performance. And it's not that the performance was great, and now also granted, these performance numbers are kind of old. This is 0.23.3. We're up to 0.23.8, and there'll probably be a 0.23.9 soon too, with more bug fixes and things. And also, the HDFS numbers, there has been a lot of work going into the newer versions of HDFS in 2.0, so these numbers are not representative of by any means of what you may actually see. But these are some performance numbers that we were running against 1.0 and R23. And so sort itself, it was 4% faster, but 4%, it's not that much. Sort with compression, there was no changes. The shuffle itself was about 13% faster. But scan, which is just kind of going through and trying to read data from HDFS, was 9% slower. We don't completely know why all of these things were, but the interesting one was grid mix itself, where we take a trace of all the jobs that were running in production and try and replay them on a cluster. It actually ended up being 5% faster. The numbers aren't fabulous, they aren't stellar, but they're close enough that you're probably not going to see any performance differences at all when you move to to Yarn. It's on par with what you had previously. It may be a little bit faster. But there are a number of other things that were added in too that were great for us, like web services. We had a lot of things where there were only certain pieces of information that were available on the web UI. And we had people who were trying to scrape the web UI to pull that information off, which is really painful. We should never have anybody scraping web pages. That's just dumb. So we added in lots of RESTful APIs to be able to pull off all the same information that's on the web pages. So now you can get information from the resource manager about all the apps that are running, how much of the queue that they're using. You can go talk to the node manager and see what apps it's running. You can talk to the history server or the MR app master and pull off the information about all the MapReduce jobs that have run and get MapReduce specific information. Another thing is that log aggregation. That putting the logs in HDFS is actually quite useful in some cases. That we've been able to do some very deep analytics on the actual logs themselves to be able to run a MapReduce job that then looks at all the output of all the other MapReduce jobs, not the output, but the logs of all those MapReduce jobs, and be able to tell us something about what's been going on there. And these are all great and wonderful things, but And one of the big things that we're really excited about is running non-MapReduce applications. We aren't currently running much of anything except MapReduce, but we're in the process of having Storm on Yarn. If you didn't see Andy Fang's talk earlier yesterday, that should be coming very shortly. Tez we're quite excited about. And then we also are in the process of putting Spark on top of Yarn. So Spark right now supports running on top of Yarn with some code that we've contributed back. We're in the process of making sure that it's secure. We can't really run it on top of our clusters until we know that security is everywhere. The security guys just won't let us. So we're hopefully by the end of this quarter, if not early next quarter, everything should be secure on top of Spark, and we'll be running with that on Yarn in production. But the biggest thing by far, more than anything else, is the total capacity that we've been able to see on our grids. So we have one grid in particular, which is about a 25,000 node grid. Now, you have to understand, we do tech refresh, so there were, when it was still 1.0, we added a couple hundred nodes to this 2,500 nodes that were newer hardware, but for the most part, the hardware has remained fairly unchanged. When we started out with 1.0, we were running about 80,000 jobs a day, and it was pegged at the maximum it could handle. The job tracker couldn't really schedule any more jobs. It was at its limits. Well, at about the same time as us upgrading to 23, there were a number of jobs that were being shifted around. Like I said earlier, we recently released, we recently got rid of two big clusters. We're no longer at about 40,000 nodes, we're closer to 30,000 nodes. These were really old clusters that were sitting in colos that were going away. And as part of this, we were moving jobs around, shifting them from these clusters to new clusters. And we moved a significant number of jobs onto this cluster. So no longer were we running 80,000 jobs a day. We now run close to 125,000 jobs a day. We peaked at 150,000 jobs a day on this one cluster. That's a 50% increase as to the total capacity that we were able to use on this cluster. That's like I added in 1,000 new servers, not 200 servers, which is what we actually did, but 1,000 new servers. That's massive. And going back and looking at why we were able to do this, the primary reason is we removed the artificial split between maps and reduces. So in MRV1, every single node you say, there's going to be this many map slots, there's going to be this many reduce slots. Well, if I'm running a big job that has lots of maps, the reduces are sitting empty and nobody is using them. Or if I have a big job that has lots of reduces, those reduces are being used and maybe the maps aren't being used at all. And so at many points in time, I may have half my cluster completely idle. Now we tried really hard to make sure that we tuned these values just right so that the jobs that we typically use will fill the cluster fairly well. But obviously from this, we didn't do that great of a job. I mean, we tried hard. We spent a lot of time trying to tune things just right. We wrote all kinds of scripts to try and make sure from historical data that we were adjusting the values just right. But simply removing that split gave us a massive amount of new capacity that we were able to take advantage of. We also think that there was quite a bit just from simply launching tasks faster and being able to have the AM there to be able to track that and the scalability of that versus the job tracker. Because like I said before, we were fairly close to maxing out the job tracker on this particular node. But that for us is huge. We haven't replaced those two clusters yet, those 4,000 nodes, because we don't really need to at this point. We are looking at adding in new nodes to some of these other clusters in the near future, but for the past year, as we've been running 23, we have not really been replacing those other two clusters that disappeared. We just haven't had to yet, which is really fabulous for us. So, in conclusion, upgrading to 23 from 1.0, it took some effort, it took some planning. It was a bit painful, but it wasn't that bad. And for us, it was well worth the effort, just from the sheer extra capacity that we were able to use on top of our clusters. So I'm happy to take any questions you might have. No questions. I must have done good.
I'm just wondering the plan from Yahoo about multi-resource scheduling policies.
About what?
Multi-resource scheduling, since from what I know, the current container only just schedule the task according to the size of memory on each node, right?
Yeah, so one of the differences between 23 and 2.0 is how scheduling works a little bit. So in 23, you ask for a specific amount of memory. So you'll say, I want a container that is 1 gigabyte in size, or 2 gigabytes in size, or 5 gigabytes in size. In 2.0, they also added in the concept of scheduling for CPU also. And this is more being able to build it up so that you'll be able to run other paradigms besides MapReduce. So in 1.0, you have the concept of a slot. And a slot actually was tied to a certain amount of memory. And so in 23, it's still fairly equivalent to what you had. In 2.0, there's also this CPU scheduling concept. For the most part, if you ignore it, it'll probably work fairly well, but we haven't done too much with that at this point to really know for sure how well the CPU scheduling is going to impact what our jobs are doing.
So there were two numbers you showed in what didn't work for you. One was, you said there was 50% more write workload.
Yes.
Given the same number of jobs. And the second bit was there was 160% more renames. Can you talk about where they come from?
I can probably talk about that a bit. Let me see if I can go back to that. Yeah. So I didn't really collect these numbers myself. I have a colleague who collected these numbers. He went through the edit log, well, not the edit log, the audit log for HDFS, scanning through those and trying to collect these numbers. So specifically, the rename operations are happening a lot because of both the way that the output committer happens on HDFS has been changed slightly for MapReduce. So we're doing more renames than we were doing before. And a lot of this is also happening because of those the MapReduce edit log, the history log that's being written out, because it's getting some renames that are happening also. So the renames are quite a bit higher, most likely because of this. As far as the create add blocks, fsyncs, most of those are probably tied fairly closely to the log aggregation. But putting those two together was when we got to a 50% higher write load. So that's essentially 50% more write operations that were happening per second for the name node.
So have you ever tried run JDK 7 on with Yarn? Did you see any performance improve?
Which servers?
Have you ever tried run JDK 7 with Yarn? JDK 1.7.
Oh, yeah, JDK 7. Yes, we're currently running JDK 7 in production. That we got a lot of lift from especially, so we first started running JDK 7 in production on just the name node and the resource manager. And that's because our name nodes are about 64 gigabyte heaps. They're very large, and the JDK 7 gave us a whole lot more performance in the garbage collection associated with that. We did start rolling out JDK 7 to all of the nodes, and I think we are all JDK 7 at this point. So we're running with it in production. We have seen a few minor issues. We found one bug in the JDK that Oracle is in the process of fixing, and we ran into one issue with strings where if you're doing lots and lots of very big substrings in JDK 7, it's not nearly as performant as it was before. Beyond that, we didn't really see too many issues.
So there's definitely a black art coming up with the number of threads, maps, and reduces on MR1. What was the utilization on your nodes that you saw when you went to Yarn, when you got that huge improvement? I mean, were you like at 40, 50% utilization in MR1, so you know there was a lot of threads and stuff not being used, and then when you went to Yarn, you're at 70, 80%? Can you talk to that?
Yeah. So I've collected some numbers on that. The numbers I collected were based off of the CPU time millis that's reported back in the container metrics. So prior to 1.0, we were operating at about 4 cores pegged on each node. On average, 4 cores pegged 24 hours a day, 7 days a week on all the nodes. It's a little hard to say whether that was 60% or whatever else, just simply because the nodes are different. They're not all homogeneous. But when we went to 23, we're closer to 7 cores pegged 24 hours a day, and we've gotten as high as 9. Now, most of the boxes are actually 8-core boxes. We run them with 16 threads because they're hyper-threaded. So you're looking at 60, 70% utilization at this point. But if we actually look at the slot utilization, the memory scheduling, we hit 100% very regularly on this grid.
Can you touch again on the HDFS incompatibility? What does that mean? It means that if I already have data on HDFS and I upgrade, I'm going to lose the data, or?
No, it upgrades just fine. So there are scripts in place. When you go to upgrade the name node, you run a command that says name node upgrade, and it will upgrade the edit logs. It will read the old edit logs, write new edit logs. You should be able to upgrade in place, no problem. Okay, well, thank you.